Last time. Okay. So we have seen SQL in all its various forms, and we're moving towards all of the different versions of it. So SQL primarily is used to query and manipulate data. We spent last week looking at how we extract data. We're spending this week looking at how we alter data that's in the database. So how do we insert new rows? How do we update existing rows to change details? And how do we delete data from that? And we covered those three statements on Tuesday. What we're going to do today is we're going to have a little recap on how where works, because where is the clause that you use to select what rows we change. So we use it in a select query to select which rows come out of the database, which rows match, which rows we want to see in the results set. We use it in an update, we use it in a delete to specify which rows we're going to update and which rows we're going to delete. And then we're going to have a look at a few examples. I'm just going to run through PHPMyAdmin and have a look at doing some updates, basically, and some of the different outputs that you get, and we'll come back to those two very good questions at the end. Next week, we're going to segue into looking at SQL as a DDL, as a data description language. What we're going to look at there is how do you actually create tables, how do you create schemas, how do you set constraints where you say, okay, so we have our logical model and we say every order must have one customer. How do we enforce that? How do we make it so the database won't accept an order that's created for a customer that doesn't exist? How do we ensure that if we delete a customer, we also delete the orders and we don't delete orphaned records? We ensure the referential integrity of our database. That's what we're going to be looking at next week. So to start off then, as I mentioned to you, we use where an awful lot. Whenever we are picking some rows and not others, so for every operation on data other than an insert, we use where to specify which rows we match to come out. So where determines which rows to match on a select or are updated when we run them against an insert, an update or a delete. Technically, where is what we call a logical predicate. Where is either true or false. So we make a series of rules in our where clause. We say the name must be Fred and the age must be over 18 and it must be a Tuesday and they must have this date. We make a series of statements and they are a simple logical predicate. We put them together and they evaluate into true or false. For every row in the database, are these things true or are they false? Does it match the rule or doesn't it match the rule? If it matches the rule, it becomes part of our candidate set. It's either output from a select, or if we're updating or deleting it, it's updated or deleted. So that's it. It's fairly straightforward. That's what we use. And when we're putting it together, we use simple statements. We say field operator value. So is name equal to this? Is the age greater than this? Is the difference between these two fields greater or less than this? And we can also then chain these things together using the and the or. So we say I want students whose name is Fred or their surname is Jones. Or I could say I want students whose surname is Jones and the first name is Fred. And these are akin to the set operators that we saw a few weeks ago. So and is an intersection. When I say and, I only want the data set that matches both sides of our predicate. If I say or, I want data that matches one or the other. So it's the difference between and being an intersection and or being a union of the data sets. There's a lot of numerical operators we can use. We operate a lot on numerical data. So we might say, give me a list of invoices who are older than 30 days. Give me a list of customers whose balance is greater than £10,000. And these are the sort of standard numerical operators that you're pretty used to using everywhere, in maths or in Java or in any programming language. So equal, greater than or equal to, less than or equal to, and not equal to. So sort of standard mathematical operators. Text is a little bit more complicated. When we want to match text, we can use equals. And equals is the strings must match exactly regardless of case. So it's a case-insensitive equals, but they must have the same content. They must be spaced the same. They must contain exactly the same characters. And if we want to be less specific with text, if we want to search a little bit more widely, we can use the like keyword. And so when we say, I want this text field to be like, and we can give it a pattern that we want to put in. And that might be a text string. We can also start using things like wildcard characters. In this case, the % means any number of any characters. So if I search for %Smith%, any string that contains Smith as a continuous string of characters anywhere in it will be found and will be matched and will be returned. In order to make our lives both easier and more complicated, we often have very complex where clauses where we want to use brackets to be really, really clear about the precedence. What is the order of which we do things? How is it evaluated? Is it evaluated left to right or and or? So if we're trying to select a set of data here, and I say give me the row or columns for the pet name Tiddles, I can quite easily just use an equals sign on a text query, select star from pet where name equals Tiddles, and we'll get one row out because that was the only row that matched it. Likewise, if that query was update or delete, again, that row would match it and the operation would only be performed on a single row. Everything ending in O, we can use the text like match, so like %O. And now we get more complicated. We say, okay, well, I want all the pets whose names end in S or E. So here we have two likes, we have two predicates. We say I want name like %S, so it ends in an S, anything with an S at the end, or name like %E, so there are two sides to this. So it's a union. If they end in S or they end in E, we'll get the entire set out the other end. And we often want to use brackets then to clarify things. So if I said, give me all the pets whose names end in S or E and are 6 or older, there's a few different ways that we can interpret that. Do we either want to say, if this was our query, what are we saying? Are we saying everything that ends with S and everything that ends with E and are 6 or older, so only the ones that end in E we care about the age of? Or are we saying that actually we want all of the that end in S and E, and then of that set, we only want all of those that are 6 or older. So it can be ambiguous in terms of the statement, so we want to try and make it a bit clearer. So we do that with brackets. So if we did just I want all the pets whose names end in S, regardless of their age, and additionally, I want all the pets whose names end in E and are greater than older than 6, that would be the query. We put the brackets in, we put it around the and, this is true, or this and this are true. So we now have two predicates. We analyze the brackets first. Remember, just as in mathematics, we expand the brackets first. So we go through and we say, okay, does it match this rule? Is the name like %E and the age greater than or equal to 6? If that is false, then we'll go and say, well, is the name like %S? And if that is false, then neither are true, and it won't be in the set that comes out the other end. If, however, what I'm asking for is the pets, give me the set, everyone that ends in S or E as a set, and then all of those, I only want the ones older than 6, we can move the brackets, we can put them somewhere else, and we can make it explicit. It's always better to be explicit than implicit. Let's state very clearly what we mean. There's no more efficiency being lost in any of this because the system is very clever and it will optimize out any problems as we go along. These are just copied slides, so we have everything there. So that's a quick recap on where. And it's important to get your where game very good because we use them all the time. We use them in selects, we use them in updates, we use them in deletes, and you might think, well, actually, most of the time the queries are pretty straightforward. Give me this where one column is true, where a name is this. In real-world databases, we often end up with hugely convoluted and complicated where clauses. One of the things that we will come on to look at in coming weeks is how do we work not just with one table of pets, but with all of the tables in the database. You saw the Northwind database that we used in the practical this week. We'll be revisiting that, and we'll be able to run queries that don't just operate on one table, but operate on 5 or 6 or 7 tables simultaneously. And we have very, very complicated where clauses. So in a database, we're able to say, well, give me the name of the customer, but only customers who've placed orders in the last 6 months and where those orders have had a certain product in. And we can link all these tables together. But the where clauses become incredibly complicated because we need to put a variety of rules in across multiple tables. So where is something that's worth repeating to yourself and going through to try and do it. Let's have a look and see if anyone's asked any questions on that bit. See, I'm good. I remember. I don't just carry on. Can you be our lecturer for CSC1021? No. What's this class test on? Missed the last few lectures. Well, thank you for your honesty. Shall I cover that now quickly? All right. So there's a slide here, isn't there, right at the start of this lecture. Let's go and have a quick look at that. Here we go, look at this for interactivity. So the class test is in week 7. Now the other thing that I've been asked about is, and I've covered this already, is what's the shape, format, blah, blah, blah. So let's just talk about all of this. The class test is in week 7, and the class test is on the design part of databases. So the lectures that are relevant are the lectures from weeks 1 and 3. So lectures 1, 2, 3, 6, and 7. And the practicals that are relevant are the ones from week 2 and week 4. So practicals 1 and 3, because we started a week late, so we did practical 1 in week 2. The format it will take will be a written paper test. I am aware that there are some people who have arrangements to do it on computer. That's fine. You'll be hearing from me in due course about that. But for the majority of people, it will be a handwritten test. And it will be about all of these elements. So there will be a question about, here's a description of a business, identify the entities, do some entity mapping. You'll be expected to do entity relationship diagrams, understand what those diagrams look like and what they can do. And there will also be definitely some normalization and some turning that into data types. So going all the way from, here's a description, through the different stages. It won't be one continuous example. I'll give you things at different, because otherwise, if something goes wrong for you on question 1, and question 2 says, take the output from question 1, 3 is from 2, and so on, it's a bit of a pain in the behind. So question 1 will be the first part of the modelling, question 2 will be the second, question 3 will be the third, and so on, but I'll give you data at each point. So if you really struggle with question 1, don't worry, you can move on and have a go at question 2. So this is what's covered. It will be paper-based. It will be a 60-minute course test. I'm fairly sure 60 minutes should do it. I'm waiting for it to be moderated, so it might come back and we'll make it a bit longer, but it will be at least 60 minutes, and it will be in your normal lab sessions. So you'll just come in to your normal lab session, whether that's at 9 or 11. Please be on time. It'll be exam conditions, so you'll come in, sit down, and then we'll give you a physical answer sheet and you'll start off. I hope that answers the questions, whoever has unfortunately not been here for the last couple of weeks. Is everyone happy enough with that? Any other explanations needed? Other than the answers, maybe? No? Okay. I don't imagine it's going to be too difficult. If you've done the practicals, and my understanding is, based on the feedback from the demonstrators, that the practicals went fairly well. If you've done the practicals and you're happy enough, you will be fine. That's what I would say. So that's the class test. Right, deleting everything. So what happens when we want to empty a table of data? We have our list of pets, and there's been a terrible, terrible accident. They need to be deleted. Our list of students, and you've all decided to quit. So how do we delete everything in our table? Well, you've obviously seen the delete command, the delete verb that we use. And really, there's two ways we can do it. We can use a delete from table with no where clause. I say delete from pet, semicolon, no where clause, hit enter. All of the rows match because there's no where clause and all of the rows are deleted. There is, however, another command which is slightly subtly different, which is truncate. So if I want to delete, I can say delete from pet, or I can just say truncate pet, and it will delete it. And there are subtle differences between these two, and there are different use cases that you'll have for them, depending on how you wish to work. So the first thing is that delete just does the row data. There is also a bunch of data stored by the table, about the table, called the metadata that surrounds it. And the most obvious example of this is the auto increment field. You know, we covered on Tuesday, if I insert a new pet into the table, the number that that pet is given, the pet ID, is automatically incremented. The system knows what the next one is, the next free one is. So if I just do delete from pet, I can delete the row data, but the metadata is unaffected, all the surrounding data with the table. Delete commands can be logged. Now, this is something that we'll come on to in a fair few weeks, actually. How do you synchronize SQL databases? How do you keep logs of changes? How do you roll changes back? The way you do it is you keep a log. You keep a list of all of the SQL commands that are run, and you know the state, and then you can run them in sequence. So it's called logging. We will look at that. But delete can be logged. Delete is just another SQL command. So delete from is just a standard SQL command, and we can run it and we can delete it. Truncate, on the other hand, is a more serious form of delete. Truncate doesn't worry about matching rows. Truncate can't be used with the where clause. Truncate will always delete all of the data. But truncate also clears all the rows, but also resets the metadata. So it resets things like incremental keys. It deletes them within it. So the easiest way to see that is to actually run it on data. We have a look at the two differences between them. So if we have a simple table called people, and we have two columns, we have an ID. ID is a number, it's an integer number, it's the primary key, and it's automatically incrementing. So it's set that every time we insert a new person, they're automatically given a new number, and then we have the name as a character field. We insert a few values into it, Bob Smith and Alice Jones, and then we have a selection and we have a look. So we've inserted these people, we haven't given the ID, because ID is an auto increment, it's a new table, starts at 0, it's given Bob Smith 1, Alice Jones 2, and if we were to insert a third person, it would give them ID 3, 4, 5, 6, and so on and so forth. So that's a steady standard table with an auto increment in it. So if we delete the data and just use delete from people, all the rows match, both the rows, no where clause, they're deleted, and then we add someone new into the table. What we get is that Albert someone is added. The previous two are deleted, of course, because we ran the delete command, but because we haven't cleared the metadata on the table, because we used delete, the auto increment field remains where it was, and the next one is given a number 3, one after will be 4, 5, 6, and so on. Truncate, the opposite is true. So if we now truncate people, we get exactly the same, we get an empty table, but then when I insert someone, the ID starts again from position 1. So the auto increment counter is reset as we go along. There are reasons why we would want to consider which one of these to use. If I just run a delete, I save the space on the disk, the records are deleted, your data is gone, so I can't necessarily get it back, but the uniqueness of the primary key is kept. If later on there's some orphan record floating around and it points towards person ID 1, I know that that ID 1 is never going to be reassigned to somebody else. The auto increment counter is still high, there's no danger of it being reassigned to someone else. But at the same time, I am going to not be able to reuse all of these lower numbers. So if I have millions and millions of people in my database, my ID number might have already reached 16 million, and I may well want to reset that back to 0, because otherwise I'm going to run out of space for whatever type of integer it is that I'm using to increment. If, however, I truncate, okay, fine, data's gone, data's deleted, exactly the same, I get the disk space back. But now I create a new person, their ID is almost certainly going to be the same as someone who has previously existed, a record that's previously existed in the database. So if I find some referential record at some point, it will appear to point towards that person. So I delete someone from the database, I create someone else, and then later on I find a record saying this person owes me 20 quid. The person ID who owes me 20 quid was person 1. Well, it now looks like whoever has that ID owes me £20. So that's why we use the two different cases, and it's important to remember them. Truncate is also a heck of a lot faster. So if I just have a set of data and I'm using it for development purposes and I just want a new kit, or if I have something where I know I don't care about integrity, I've got a logging file, I've got a logging table that just takes all these events, and it doesn't matter, they don't rely on anything, I never use their key anywhere else as a foreign key, then I would use truncate. Truncate happens very quickly within the database, and it's incredibly fast and incredibly efficient. So those are the two different ways of working. Let's have a quick look at today's meet. Excellent, same questions. I assume you're not asking different people asking it. So let's have a quick look at some SQL then. Let's look at something a bit more exciting than just PowerPoint slides. Let's have a quick look at SQL. All right, so here is PHPMyAdmin. It might look a bit different to the version you use. I think this is a newer version. I'm just running it on my laptop because the Wi-Fi is terrible. And here I have a database. in which I have the famous pet table and various other bits and bobs. Now, before we have a look at the commands we've been talking about for the last few days, I now want to come back to the questions that I was asked. A couple of people asked very, very good questions. So the first one is someone said sometimes SQL seems to accept single quotes, sometimes it accepts double quotes, but there doesn't seem to be any rhyme or reason to it. Now, I'm not sure what's going on there. I have a theory, which might or might not be wrong. So as I mentioned to you last time, if we have a query, right, so we have, let's say, where name equals, do we have a dog called Fido? Oops, can't type now. Assume we have a dog called Fido. Well, that's brilliant, isn't it? Oh, I haven't put the table name in. Look at me, I know databases. Right. Hey, there we go. Okay, can everyone read that all right? Yeah, okay. So here we are, we've run a query now, we select staff from pet where name equals Fido, and as I mentioned to you, we're using double quotes here, and what I said last week was we can use double quotes or we can use single quotes, but we can't use a mixture of the two. So if I use a mixture here, it's already said it's not very happy, but when I run it, you'll see you get a nice error, ending quote was expected, blah, blah, blah. So we'll change this over to use single quotes, and we'll run go, and it does work. So the simple answer to the question is why can I sometimes use double quotes, sometimes use single quotes, is you can't. You should be able to use double or single quotes wherever you want, as long as you use them consistently. Now, what I'm not sure, and I will just check while you're here, is if we can use them intermingled within the same query. Yeah, looks fine. Oh, or not. Should that have matched? Have I misspelt it? It's not type, it wasn't breed, was it? It was type equals dog. Yeah, okay. So I don't really see, there's no reason why you shouldn't be able to use single and double quotes and mix them as long as each string is terminated by them. My working theory for why you have a problem is Microsoft Word. So a lot of the examples that I give you, the SQL examples, I've done in Microsoft Word, and Microsoft Word has a habit, a nasty habit, of doing what it calls smart quotes. So when you put this thing into Word, oh my God, I can't even read that. What am I saying? No, let's go for 500%. Oh, okay, right. Now we're really looking at Word, aren't we? Right. So if I put a query into here, because I'm writing it in Word, because that's how I write your. What you'll see is that Word has used these stupid stylized smart quotes that it uses. And if I now copy this and go off into here and put it into PHPMyAdmin, doesn't like it, because it doesn't see these as quotes. It sees these as stupid, ridiculous smart quotes. That's my theory on what's happened, is that you're using an example that I've created in Word, or I've copied and pasted it into Word and it's gone. If whoever asked that question thinks something different, come and see me and we'll have a look at it. But you should just be able to use single or double quotes interchangeably as you wish to use it. And I'm sure even if we use the actual MySQL so this is the actual command line interface that you all, don't worry, this isn't the matrix, this is the actual command line interface that's used, is we can do that. This is how I talk to MySQL. Yeah, so even in the actual interface, single quotes, double quotes can be used interchangeably, but I'm fairly sure that if we, even in here, try and put in the smart quotes, yeah, so that's almost certainly the problem. So be a bit cautious about copying and pasting SQL in from Word documents, because it looks like it doesn't behave very well. So the other excellent question that I had was about null values. So you'll have seen when we had a look at the pet table and we were looking at it, that when I inserted a row, so let's just insert So insert into pet, name, let's insert a pet called Henry. We run go. So that's our insert query. What we had was we had a null value at the bottom here. And someone said in the question, is null the same as an empty string? And that is it's a very, very good question. No, it's not. Null is a very special type in MySQL. What it means is it means there's nothing there. An empty string is exactly that. It is a character string that's available to be assigned, but it has no characters within it. Null is a lack of a value. An empty string might well be a valid entry. Some of you will have middle names, some of you won't have middle names. So if I had forename, middle name, surname, you might well have a middle name that would be an empty string, but it wouldn't necessarily be null. Null is a very specific value. If you're interested, which I'm sure you all are, if you Google MySQL null, there is an excellent description on the MySQL website, which is now what it's going to ask me to, I don't care, about what null is and how you use it. But the important thing is that it's not an empty string. So here we go. We've got breed here. We've got one which is empty and one which is null. So if I now update this and I say where breed is equals quotes quotes, it will match one of them, but it's not going to match the one where it's null at the end. If we want to find something that's null, you might think, okay, well, can we say where oh, it's breed, sorry, I'm really losing the plot today, aren't I? More so than usual. Right. It's not going to work because nothing's ever simple in SQL, and we can't just compare a null value. We can't say equal to null because null isn't real. So what we have to use is we have to use the is keyword, and that will find records which are null. So it's a subtle semantic difference, is that null is an absence of anything, whereas an empty string is exactly that. It's still a string, but it's a string that contains no characters. Now we can control whether we want to make fields what are called nullable or not. Can it be null? Can't it be null? So if we have a look at the structure of the pet table, what you'll see here is that most of the fields we can't assign a null value to, but breed we can assign a null value to. It's nullable, so this column is yes, and the default value is null. So when we insert something where we haven't specified a breed, these will have no default, so they will be an empty string, but this is null, so it will default to null. So that's basically what goes on. So let's have a look then at what we were doing in terms of data manipulations. The first thing is we were looking at how do we insert data into tables, and we've already done that once. So the syntax is we just say insert into provide a relation or a table name. So in this case, we're operating on a pet table. And now we provide a list of fields within brackets. So what are the records we want to put in? What are the columns that we want to fill? So we want to insert into pet. We want to give it a name, a type, a breed, and an age. Oops. And then we specify the values. So we're going to input something called fish. It is a cat. It's a tabby cat. And it is 9 years old. So we just specify this. So we're saying insert into pet. Here's the table name that we're using. Open bracket. What are the columns that we're inserting against? And then finally, what are the values that we want to go? And we just run this and insert it. Now what you'll see is that when you use this through PHPMyAdmin, it gives you a nice little bit of feedback. It says, okay, one row is inserted and the inserted row ID is 110. So we know that we've inserted a row and we've done it. Inserting data is pretty straightforward. As long as we name the columns, we give the right type of data, then we're good to go. We get errors if we put the wrong type of data in. So for example, here we've got pet ID, we're letting that assign itself. We've got 3 character arrays, and we've got an age which is 11. If we attempt to insert some data, let's have a look. So if we now insert into pet, and we're just going to give it a name and an age. So we're inserting here, the columns are name and age, and we're giving 2 values, Bob and 10. what should happen, oh, okay. What I expected to happen, and obviously nothing ever goes to plan, is that would give us a nice error. It would say you can't insert that type of data. For some reason, it's decided just to ignore that field and put it in. What we can do is generate errors. Let me force an error. If we try and insert nulls into non-null data, what I just wanted to show you if we try and create records on non-nullable fields and we run it, this is what we get. So if we try and do a query which it can't do, and I'm not really sure, I think my version of MySQL maybe has got some kind of safety check turned off. If we try and insert something which doesn't match, in this case we're trying to insert null values into name which cannot be null, then we'll get a nice error back that tells us what the actual cause of it is. But that's fundamentally how we insert data, so we use insert into. The next thing we looked at was how do we change data that's already been inserted, and we do that with the update. So update's the verb we use. Update the table that we're going to update, so in this case we're going to update the pet table. Set, and now we literally just give a list of columns equals value. So column name that we're going to update and the value that we're going to update it to. So let's set the type equals something, age equals 200, and then we can just specify a where query as to which rows match the predicate, and then which rows are updated. So in this case, we executed a query, we executed update 109, we set the type to something, and we went in there. We can also do things like reference fields to each other. So we can say here, update pet, set age equals age plus 1. So go through on every column, set the age column to be what it already is, plus 1. And we can also use mathematical operators, so we can make everything double in age. Run that and do whatever. So we've now got a 400-year-old something at the bottom. So when we use update, we just see the general form is update, the table we're updating, set, key equals value, comma, key equals value, comma, key equals value, and we can update those as we go along. And then exactly like a select, we use the same where clause to determine which ones are updated. And the logic is exactly the same. If we run a select and the data comes out the other end, matching the where clause, we run an update and the data goes in and shows that. One of the interesting things, I find it fascinating, in terms of how updates work is the feedback that you get out of it. So let's set an update. So if we say update pet, set age equals 13, where pet ID equals 103. So what I'm going to do now is, here's record 103, doggo the dog is actually 13, is not 12. So we can run this query, it's going to set the age to 13 where pet ID equals 103. So we run that. One row affected, query took whatever number of seconds it took, small amount of time. And when we browse our table, you'll see that, boom, here he is, he's been updated to 13. Let's run the same query again. The query's run, it ran successfully. We got a nice green tick at the end, meaning it had run fine. However, the response we got out was no rows are affected. Now that happened for one of two reasons. Either no rows matched the query. We asked it to set the age of a dog that doesn't exist. We set a pet ID in our where clause that wasn't found, it didn't exist. In this case, we know that's not the case because there is a pet with an ID of 103. In this case, it's the second reason. We ran an update, but what it's saying is nothing changed. We executed it, the query ran, it was syntactically correct, it ran okay, we get a nice green tick. It matched a row, but we were asking it to set age as 13 where pet ID is 103 because the age was already 13. So what this is saying is it's not how many rows were matched, it's how many rows were affected, how many rows were actually changed. And this is often an error that people come across. They say, well, I ran an update clause to set all these fields, and it should have matched 100 records, but it's only said it affected 50. Well, that's fine. It may well have matched 100, but it's only changed 50 because 50 were already that setting. So the number updated will only be the number that's shown at the end of it. So that's update. An update, again, I think is relatively straightforward as long as you get your head round where and you go through it all carefully. Can I zoom in? Yes. Yes, I can. There we go. Probably too late now. You've missed it. It's on a video, though. I am recording this. Someone said in the feedback, can you record all the lectures? I do record all the lectures. The exception is last Thursday where I forgot to hit the record button. So I am sorry about that. But kind of, you know, these things happen. What I will just say as a quick aside, right, is that when I'm setting up, this is the recorder I use. And you see the little red dot? It means that I'm recording. If I stumble to the beginning of the lecture, drunkenly wake up enough to start talking to you, and that is not red, and you can see the toolbar, someone shout or throw something at me, all right? But hopefully I'll be better, okay, and I'll remember. Anyway, right. So we do record all the lectures, and I'll put them up usually on the Friday. Right. So we've done insert, update, and the last one then straightforwardly is delete. And delete is, again, pretty straightforward, I think. Syntax, delete from the table. And then if we did that, we have no where clause, the same as select or update. No where clause means all rows, so we would delete everything. Or we go through and we happily put in our clause or our query. PHPMyAdmin, because it holds our hands, because we can't be trusted, comes up and says straight away, because it's a delete query, you're really sure you want to execute delete from pet, and I am, because I'm maverick like that. There we go. It's deleted. One row has been affected. And when we go back, oops, no, I didn't want to do that. I wanted to just select this like that. When we go back and have a look, what we should find is that pet 109 has been deleted. And as I say, the where clause syntax is exactly the same for all of these. It's the same things we can use a predicate. Exactly the same as update. If I run it again, yes, I'm really sure. You'll see that it runs, syntactically correct, it ran, but no rows were affected because it didn't match a row with pet ID 109. That was it. It was that simple. If I want to delete everything, we put that in. We do nothing. We go on. Next time, are you really sure? Yeah. All the rows matched, all 10 rows matched, and now when we query it, we have an empty set which goes on. Which means, luckily for you, I've basically run out of SQL lines to show you how things work because I've deleted the data. So let's have another quick look. Does anyone have any questions before we